June 2014, S1, question 5. Okay, so if X is the number of female puppies, right, X has got a binomial distribution, right, because N is 20 and P is 0.55. Okay, follows the classic setup for binomial distribution. For AI, then, the probability that X is equal to 12, then I use my formula with N is 20, P is 0.55, and then 1 minus P is 0.45. I put that through my formula, and it gives me the probability is 0.162. For part B, then, for X to be inclusive of those values, well, I need X is less than or equal to 16, take away X is less than or equal to 7. So this is ready for me to look up in my binomial tables. Now, I can't look at the tables because P is 0.55 and it's too big. So I have to look at the opposite viewpoint of male puppies where Y is binomial 20, 0.45. I've written down my values of X and the equivalent values of Y. So what I'm actually looking at then is I need Y is less than or equal to 12, take away Y is less than or equal to 3. And I'll go to my binomial tables with N is 20, P is 0.45. I look up those two values, which is 0.9420, take away 0.0049, which gives me the answer 0.9371. Okay, for part B then, it's the same setup where X is a binomial distribution and they need us to use a distributional approximation. So I go from my binomial to my Poisson, where the Poisson mean is the same mean from the binomial of N times P, so that equals 3. And I'll work out the rest of it. X is less than 5 as a Poisson probability where X is less than or equal to 4. So let's go to our Poisson tables with mean 3, look up the 4 value, and there's my answer, 0.8153.